Okay, so hopefully you found the examples under teams and under handouts and then under momentum and energy. So I just put the top stuff there to remind you in case you hadn't written it down. There are different types of collisions, and so down below I did different examples. So the first one, 100-kilogram car, initially traveling 24 meters per second east. So V1 initial, 24 meters per second, and it's 100 kgs. And it's going to strike a 80-kilogram car initially at rest. So this is 80 kgs, and V2 initial is 0. And then it says after the collision, the 100 is still traveling east, so V1 final, it's just now, it is 10 meters per second. That's east. And it wants to know what's V2F. Okay, so M1 V1 initial plus M2 V2 initial will equal M1 V1 final plus M2 V2 final. The V2 initial is 0 because it's at rest, and we're looking for V2 final. So it'll be M1 V1 initial minus M1 V1 final. We're going to take it over. Equals M2 V2 final, and now divide by M2. So V2 final will equal M1 V1 initial minus M1 V1 final divided by M2. Both of these are going east, so they're both going to go in as a positive. So it'll be 100 kilograms times 24 meters per second minus 100 kilograms times 10 meters per second. And then that's going to get divided by 80 kilograms. So 24 with 2 zeros minus 1,000, 14 with 2 zeros divided by 8, 140 divided by 8. You will end up getting V2 final to be 17.5 meters per second, works out to be positive, which means it's going east. And that should make sense, because this one was going east to begin with, it slows down, so this one must pick up going east. Okay, so that's the first example. Example number 2. A 5-kilogram cart moving 2 meters per second north. So this is 5 kgs. And V1 initial is 2 meters per second north, and I'm still drawing it to the right even though it says north. And an 8-kilogram cart now moving 4 meters per second to the south. So this is 8 kilograms, and it's moving in the opposite direction. So V2 initial, 4 meters per second south. When they collide, after the collision, the 5-kilogram cart rebounds at a speed of 1 meter per second. So if it rebounds, then it means V1 final is 1 meter per second south. Rebound means going in the opposite direction. What is the final velocity of the second one? What is V2F? So again, M1 V1 initial plus M2 V2 initial will equal M1 V1 final plus M2 V2 final. Nothing goes to 0. We're solving for V2 final, so we're going to take our M1 V1 final over, subtracting it. So V2 minus M1 V1F. And then to get the V2F alone, you need to divide by the M2 again. This time you do have to worry about directions. So let's call north positive and south negative. So M1, 5 kilograms, V1 initial, positive 2 meters per second, plus M2, 8 kilograms, V2 initial, 4 meters per second south, so negative 4 meters per second, minus M1, 5 kilograms, V1 final is 1 meter per second south, so negative 1 meter per second. And that's all going to get divided by 8 kilograms. So the first term here will be 10 kilogram meters per second minus, that's 32 kilogram meters per second. And then this is going to be plus 5 kilogram meters per second over 8 kilograms. So on the top, you should end up with 15, negative 17 kilogram meters per second over 8 kilograms. So you will get a V2F of negative 2.125, I think. And what does the negative mean? It means south. And if I had enough room, I'd write it at the bottom, but since I don't, I'm going to write it up there. Okay, so the negative, just like in all other physics, you have to tell me what the negative means, and in this case it means south. All right, number 3. A 200 kilogram cart is initially, oops, I lost the question. 200 kilogram cart is initially moving 5.8 meters per second with a second cart that is stationary. I think I collides with. Okay, so first dude, 200 kilograms, V1 initial, 5.8 meters per second. Collides with the second dude, which is 225 kilograms, and V2 initial is 0. When the carts collide, they lock together. So after the collision, they're hooked. And they move off with some velocity. Obviously, if they're hooked together, means they move off with the same velocity. So what is that velocity? So M1 V1 initial plus M2 V2 initial equals M1 V1 final plus M2 V2 final. This goes to 0 because it's initially at rest. And then on this side, this is really M1 plus M2 VF, right? Because the VF is the same, and that is actually what we're looking for. So you can divide both sides by the bracket. So M1 V1 initial divided by M1 plus M2. M1 was 200 kilograms times 5.8 meters per second. There is a decimal there. Divided by 200 kilograms plus 225 kilograms. Okay? And when you do this on the top, I think you get 1,160 kilogram meters per second. That's an equals. And on the bottom, you get 425 kilograms. And so you end up with a VF, which is a common VF, of 2.7294 meters per second. And it works out to be positive, which means it's going in the original direction of the first car. Okay? Number 4. Number 4 is 2 figure skaters that are standing together on the ice. Okay? So here they are, and they're attached. One has a mass of 50 kilograms, and the other has a mass of 80 kilograms. And initially, they're not moving. So V1 initial is 0, and V2 initial is 0. Okay? And so then it says, as the music begins, they push off each other. And the 80 kilogram dude moves with the speed, so V2F of 1.5 meters per second east. So that's a final velocity. And the question wants to know, what's the final velocity of the first dude? Whoops, that's a 1. So M1 V1 initial plus M2 V2 initial will equal M1 V1 final plus M2 V2 final. These are both 0. So it'll become, bring this over, M1, negative M1 V1 final equals M2 V2 final. You're looking for V1 final, so divide. So M2 V2F over over M1, and the negative comes over here too. That really is an M1. So M2 is 80 kilograms, keep the negative, 1.5 meters per second divided by 50 kilograms. And so you get a V1F to be negative 2.4, I think, 2.40 meters per second. And what does the negative mean? He went east, so it means west.